Greetings, math fans. All right, so what we're going to do today is we're going to verify identities. Okay, and verifying identity is basically we're going to show that the left equals the right. Okay, left equals right. That's all we're going to do. So here's the key. Is we're going to simplify. We're going to simplify the more difficult side. And this is important. Do not touch the other side. Okay? Do not touch the other side. We're going to simplify one side only and not the other side. So before we actually get started, we've already talked about ways to simplify things, right? You turn it into sines and cosines. You multiply by the conjugate to simplify things. You multiply, you get a common denominator. A lot of different things to simplify some of these identities. All right. So let's just talk one thing here. Which is more difficult? All right, so we're going to compare 1 over x plus 1 over y versus 1 over x plus y. Okay, and this guy right here is a more difficult one. Okay, because it's two fractions. At least this one is combined into one fraction. This one's already in two fractions, and you just find a common denominator for this one, which would be xy. All right, so this guy right here is the more difficult one. All right, and what about, this is basic, what about x plus y versus x times y? Okay, so once again, this guy is actually the more difficult side to have addition. Okay, it's a lot easier to put things together, to get a common denominator and have things multiply together. It's more difficult to have things added together. Okay, so for example, like, if you have tangent, you could say sine over cosine plus 1 over cosine, and then you could add things together and you could combine them. But if you have an xy already, that's actually easier, and it's more difficult to break that up. Okay, so that's just kind of two important things here that I'd like to mention. And let's start doing some examples here. I have cotangent of theta over cosecant of theta equals cosine of theta. Well, obviously a lot of times it's pretty simple to figure out which one's more complicated. In this case here, obviously the left-hand side is more difficult. So what are we going to do? Remember, if all else fails, math fans, if all else fails, you want to write it in terms of sines and cosines. Okay, that's just the best way to go here. So we're going to do cosine of theta over sine of theta divided by 1 over sine of theta. Okay, so again, I'm not even going to worry about that cosine. I'm going to write that at the end. Just keep simplifying that left-hand side. And I want to see steps. If you're not sure, if you're thinking to yourself, gee, I wonder if I should show this step, then show it. Okay, so it's divided by that. So I'm going to multiply that by sine of theta over 1. And then you get cosine of theta equals cosine of theta. And this is a step where I want to see. I know it sounds a little silly, but the very last step, this needs to be carried down to here. Okay, of course this is the same, and I want to see a check mark there to show me that it is true. You proved that it was true. Okay, now the part of the question is people might ask is, are you ever going to give us something where it doesn't work out? And the answer to that question is no. It's always going to work out for you, but you always have to show me all the work behind it. Because what happens is I get some people that have they get a complicated side, and they do some little cheesy method, and all of a sudden poof, it turns into the other side, and they say, yeah, that's true. I'm going to be looking for every single step. If you're missing a step, or if you really have no clue how to do it, you're not going to get any points for it. So please don't use, we call that the CM. CM stands for cheesy method. Okay, do not use the cheesy method and miraculously come up with that the left side equals the right side and put a check mark on there. Okay, that check mark means you've done all the work behind it. All right, very important. Okay, let's try another example. tangent squared of theta plus 1 over secant of theta is equal to secant of theta. Okay, this is a pretty easy one, right? And this is just recognizing you got your identities. Remember, tangent squared of theta plus 1 equals secant squared of theta, and cotangent squared of theta plus 1 equals cosecant of squared of theta, and sine squared plus cosine squared equals 1. If you want to write all those out, and then when you see something like that and you have to manipulate it, then go ahead and do it and use it. Okay, well obviously this is an easy one. That's just secant squared of theta over secant of theta, and then that cancels with that, and we just have secant of theta equals secant of theta, check mark. Okay, it's not too bad so far. All right, let's keep going here. Sine squared of theta times 1 plus cotangent squared of theta equals 1. Now again, this is really obvious which one it is, right? Obviously you're working on the left hand side. And what do you do? Well, you're going to distribute. So sine squared of theta plus sine squared of theta cotangent squared of theta. Okay, and this one I can't really do too much, so sine squared of theta plus sine squared of theta times cosine squared of theta over sine squared of theta. Sine squares cancel out. I get sine squared of theta plus cosine squared of theta equals 1. Now you can literally substitute, as long as you can use one of your identities, you can substitute sine squared of theta plus cosine squared of theta equals 1. So 1 equals 1. Check mark. Okay. Let's try another one. Tangent of theta plus cotangent of theta equals cosecant of theta secant of theta. Okay, and what I tell you guys to do, if it's addition, that's probably more complicated. So I'm going to write that left-hand side, I'm going to write it in terms of sines and cosines. Okay, so we have sine of theta over cosine of theta plus cosine of theta over sine of theta. And we got to get a common denominator, which happens to be sine theta cosine theta. So multiply this one by sine theta over sine theta, and this one by cosine theta over cosine theta. Okay, so you get sine squared of theta plus cosine squared of theta, and it's all over sine theta cosine theta. Well, of course, the top is equal to 1, so I can do this. And then 1 over sine, this is multiplication, so 1 over sine of theta is cosecant of theta, 1 over cosine is secant of theta. There we go. Check. All right, not too bad. Let's keep going here, math fans. Here's a nice friendly one. Cosine of theta over secant of theta plus sine of theta over cosecant of theta equals secant squared of theta minus tangent squared of theta. Well, again, got two fractions on the left-hand side, probably more complicated. Okay, so you're just going to now there are a couple of things you can do. You can get a common denominator here, or you can turn things into sines and cosines. Now, as we kind of talked about before, if you get a if you turn things into sines and cosines, you're going to get everything in terms. You got a cosine here already, and you're going to get, that's going to be a cosine on the bottom. That sounds good. If I actually get a common denominator, do you guys agree that I am going to have cosecants and secants on the top and on the bottom, along with sines and cosines? And you can't really mix them, and maybe you can kind of multiply things out, but I always look for something like with things that are the same: sines and cosines, secants and tangents, cosecants and cotangents. I always kind of look for that. But it's kind of your call. So what I'm going to do is I am just going to turn things into sines and cosines, because I noticed that this guy right here is just 1 over cosine. So it's cosine of theta over 1 over cosine of theta plus sine of theta over 1 over sine of theta. And then I flip it around, cosine of theta times cosine of theta over 1 plus sine of theta times sine of theta over 1. it gives me cosine squared of theta plus sine squared of theta. Now this is the deal, math fans. If you actually had written this down, tangent squared of theta plus 1 equals secant squared of theta, you can realize that now you're not going to be able to touch this, but you can realize that's actually an identity. Okay, if I subtract tangent of theta, don't I get secant squared of theta minus tangent squared of theta equals 1? So what I'm kind of getting at here, math fans, is isn't that equal to 1? So the next step is you write 1 there, and the next step, because I know this identity, I'm allowed to rewrite that and say secant squared of theta minus tangent squared of theta. As long as I can keep substituting in, and now that's equal to that. Okay, so check. So you can't go from here to here. Can't do that. Okay, boo. Can't do that. You got to go to here first to show me it's 1, and then you can go to there. Okay, it's not too bad. Okay, let's keep going here. Got a few more examples to do with you guys. I have cosine of theta plus 1 over tangent squared of theta equals cosine of theta over secant of theta minus 1. Okay, now again, you're kind of looking at say which one is the easier one here. This side, well, which one's the more difficult side? This is actually more difficult because this has two denominators. Don't you guys agree? This other side, the left-hand side, that's actually kind of a simpler form because I can just rewrite that as cosine of theta over tangent squared of theta plus 1 over tangent squared of theta. I can kind of rewrite that pretty easily. This one, you can't just say cosine of theta over secant of theta, right? You're not allowed to do that. So the right-hand side is actually more difficult. And I know I kind of mentioned this right in the beginning here, and we haven't necessarily looked at it, but I can multiply this by the conjugate of that denominator. And the conjugate is secant of theta plus 1 over the secant of theta plus 1. Right? It's like multiplying it by 1. And what you kind of want to recognize that, because if I see secant of theta minus 1, I know I can have a squared here with a 1, and right, we have all our nice little trig Pythagorean identities, and we can probably convert something into one of those identities to simplify it. Okay? So I have, let's just kind of write that out. Cosine of theta, secant of theta plus 1. And on the bottom, I have secant squared of theta, and then the outside and inside cancel, and then minus 1. So I'm going to write this out here. Tangent squared of theta plus 1 equals secant squared of theta. Now you notice I can rewrite this guy right here based on this. Can I just subtract 1? So secant squared of theta minus 1 equals tangent squared of theta. Okay, that's really nice. So I can write as, you can do a couple steps here. How about cosine of theta, secant of theta, plus cosine of theta, all over tangent squared of theta. Okay, so we can keep going here. Cosine of theta, 1 over cosine of theta, plus cosine of theta. Alright, and that guy cancels, so I actually get 1 plus cosine of theta over tangent squared of theta. And you really kind of want to rewrite it. You could have done that in the first place. It's cosine of theta plus 1 over tangent squared of theta. And I'm going to write that out here. And check. Okay, that's it. That's pretty well. But, just, again, that's one more step, right? Multiply by the conjugate. All right, try another one here. Got a couple more to do with you guys. Let's see. How about cotangent squared of theta minus 1 over 1 plus cotangent squared of theta equals 1 minus 2 sine squared of theta. Well, definitely the bottom looks, or this left side looks a lot more complicated because it's a fraction, right? Okay, so let's choose that guy. Just for example, math fans, let's say you choose the right-hand side and you're working at it. I mean, it could work out. Sometimes it's not obvious and you choose one side or the other. As long as you can simplify and have it equal to the other side, you're good to go. If you can't simplify it, you can't figure it out, maybe then you try the other side. Okay? But you gotta try different things sometimes. Anyway, I'm gonna work on this guy right here. Definitely looks more complicated. And I see cotangents. So I'm gonna write this as cotangent squared of theta plus 1 equals cosecant squared of theta. I'm going to write that out because I'm going to just replace that. Okay, so I can't do anything with that. Do you guys agree with that? Cotangent squared of theta minus 1, because there's no way for me to manipulate this equation to give me that. So I'm going to do cotangent squared of theta minus 1, but the bottom I can substitute cosecant squared of theta. Now I have one denominator. Let's write it out. So I have cotangent squared of theta over cosecant squared of theta minus 1 over cosecant squared of theta. And I can write it in terms of sines and cosines. So cosine of squared of theta over sine squared of theta over 1 over sine squared of theta minus and then how do you deal with this one? This is 1 over cosecant squared of theta. This is the same thing as sine squared of theta. Right? So let's keep going. I got to simplify this. I'm kind of running out of room here, and I want to keep that equation on the screen here. So I'm going to get cosine squared of theta over sine squared of theta times the reciprocal of that, sine squared of theta over 1 minus sine squared of theta. That cancels, and I get cosine squared of theta minus sine squared of theta. Okay, we're still not here yet. But I want you guys, again, this is getting to be a more difficult problem as we move along here. I want you guys to understand that I've got everything in terms of sine here. Right? Everything is in terms of sine, so I want to get this in terms of sine. Well, what's cosine squared of theta? Isn't it 1 minus sine squared of theta? And then minus sine squared of theta? So it's 1 minus 2 sine squared of theta. Hey, hey! Look at that! That's what we have here, math fans. Equals 1 minus 2 sine squared of theta. Okay, we're done with that. That was pretty mellow. I like that. And one last one. It's very friendly. Sine to the 4th of theta minus cosine to the 4th of theta equals 2 sine squared of theta minus 1. Okay? It looks kind of brutal, but obviously you know to work on this side, right? Most of the time it's obvious. So isn't that a difference of 2 squares? So I can write it that way. I have sine squared of theta minus cosine squared of theta and sine squared of theta plus cosine squared of theta. Well, that's one of your identities right here, math fans, right? So that's just 1 times sine squared of theta minus cosine squared of theta. And then notice again, what is that? It's in terms of sine squared of theta. So can I substitute if I have sine squared of theta minus, and what is cosine squared of theta? 1 minus sine squared of theta. So just be careful of your algebra 2 here. And that's going to give you sine squared of theta minus 1 plus sine squared of theta. So sine squared of theta plus sine squared of theta is 2 sine squared of theta minus 1 equals 2 sine squared of theta minus 1. Okay? And that's it. That is, that's my last example here, math fans. So you guys have a bunch of problems. You have 3 days worth of problems to do, and it just takes some time and some patience, and hopefully you kind of get all these problems. But if you don't see something, again, try the sines and cosines, look for conjugates, look for common denominators, look for identities, and you should be okay. All right, that's it, math fans. Have a great day. Goodbye.